Всем привет. Меня зовут Толмачев Павел. Я сотрудник образовательного отдела компании Postgres профессиональный. И теперь я буду ведущим в данной секции до окончания данного доклада. Следующий доклад расскажет Николай Самохвалов, Артем Карташов. Это даже не доклад, а мастер-класс «Бесшовная оптимизация запросов PostgreSQL версия 2.0». В рамках данного мастер-класса докладчики разберут, как можно настроить процесс беспроблемной бесшовной оптимизации SQL-запросов в вашей организации. Какие инструменты следует выбрать в вашем конкретном случае, как эффективно заполнить вышеупомянутые проблемы в сфере анализа запросов. И передаю слово докладчику.
Спасибо. Действительно, это будет такой тренинг, мастер-класс, туториал, как угодно можете называть. Мы попробуем вложиться часа в 2, чтобы всем пойти уже отдыхать. Но это зависит от того, насколько много будет вопросов и будут ли еще технические проблемы, которые сегодня нас преследуют. Ну, по крайней мере, меня точно преследуют. Да, действительно, Артем Карташов — это ведущий инженер Postgres AI, который разработал много чего полезного из наших инструментов. Будет мне помогать. Еще раз повторю, что можно задавать вопросы в чатик, и если будет необходимость... Артем, я вижу, иногда отвечает на чатике.
Да, все так, всем привет.
Да, привет, Артем. Еще раз, если вдруг вопрос какой-то будет достойный, то мы его обсудим, да, то есть, пожалуйста, прерывайте. Демократический подход. Нет, тем более, раз это тренинг довольно долгий, то имеет смысл вопросы пачками обсуждать. Поговорим сегодня про оптимизацию в разных аспектах, оптимизацию запросов. Слайды последней версии.
It's a wrong reference, wrong link. We already have technical problems. Unfortunately, I lost slides. You know about me. We'll skip about the company. We'll not focus on that. So what are we going to discuss today? Optimization of queries. And our goals for today, this training is about seamless optimization, because we have some big gaps in the process that we want to make seamless. So that's how methodology is called that we try to develop, including with activities of our company, is dedicated to closing some of these gaps. So some gaps already closed very well, some will be closed in the future. And today we're going to discuss various tools from various developers and companies, some overview. I just found out about some tools myself recently. I have a stream through Postgres, and it's very useful. I find out about various tools myself and gradually test it in my work and even advise to my clients, and we start to use it as part of our platform. And most important item, I'm sorry that the slides are in English. They are bilingual. We have bilingual viewers. So it's important that you don't need to remember everything, but what is possible. If you know what is possible, often it happens you can come back and look and remember. If you remember some tool and you can find it and then recover. It's most important to know that it's possible to resolve this problem as a bonus for some developers. Could be useful. So step by step, we'll start with methodologies of various analysis of SQL queries, focusing on Postgres. Then we'll discuss macro level when we analyze these queries. Then we discuss, that's one of the gaps, how to switch from macro to micro. And micro analysis when we analyze one query or the chain and the load. Multi-flow is micro level is one request. So and then how to we optimize and where, and finally we'll have a summary, 3 key principles, the themes that should finally turn into seamless SQL optimization. Many of things like that are work in progress, and the tools that we develop and resolve, and there we see in other companies the vector of development to improve the processes. And we have interactive part that can be used in 2 ways. There are slots, 15 of them, and those who will be the first to go on this link, it will be great, guys. Oh, this is called Karakoda. It's a system that will give you a virtual way. As soon as you open it, if you logged in, I'm sorry there, you need to log in. There is a second way. You can go to repository and open manual and go step by step. Should be docs there. And you'll have these steps and you will repeat them. I'll be in Katakot and some people will be able to enter. And there is a third way, just can look with popcorn and do nothing. It's always better to do something. You understand it better. And ask questions, for example. Yes, it will take a few minutes. It's not very fast internet on this virtual. Can wait. And I'll emphasize those who will be there and will be doing it manually. Pay attention that on the left you can click and you will immediately have a command from left to right, but take your time, don't create it. By previous experience, people try to create it. So first request is working, second is not. I have a question. Do you see it well? Oh, I can enlarge it. It's not seen well. I will slightly enlarge it. That's how it is. So if it's all bad, we can try to improve it. So while it's been deployed about anti-methodologies, actually it's a legacy from the person who many of you know is the author of a book on system performance overall and analysis of and optimization of Linux as a whole, engineer who works in Netflix, and we all know him very well. From Grops, other instruments. He's also ZFS that we mentioned. He developed some features. So it's a very fine framed, while the virtual is deployed about under methodology. First, do nothing. Let's just increase the machine and have better disks. That's anti-methodology. It's not good. In some cases, it's justified for business, but usually it's not where we look. Streetlight, all used it, especially if you don't know the topic as a whole, and you are a beginner, DBA, or engineer, programmer, with limited knowledge on database and Postgres. You try to find problems where you know. Streetlight, where the person who lost in the dark is only looking where it's light. And this is also anti-method. There are other anti-methods, like make random things. So that's how it is. That's all anti-methods. And my favorite, blame someone else. And programmers, you can hear that database is slow, but in DBA you say you don't know how to write applications. Or GCP, they have bad network, or internet, and confining. But there are good methods. We're going to discuss it. We'll see what's up with statements. By the way, it's not just Postgres in this container, but it's with some additions. It's one of the SPG, and I recommend it. Those who use console, PSQL, but not PSQG, start using it. It's a good way to make conclusions. So, PSPG, please remember, that's what enables and you can fix it. You can fix various columns. And those who don't know, Q is exit. From the view mode, you need to press Q. Okay, you can move to the second step. Okay, let's go back to the slides, and I will jump from there, here, and then we'll discuss methods available. Brian Greger has a method, a formalized use called use utilization saturation errors. Each of the resources, CPU, and memory is considered like that. It could be applied to databases, various other approaches, and a large discussion, what is best. This is all about system performance, machine with Linux, and overall, we consider it. You can try to use this method in database management and try to use it to components of Postgres. It's a normal approach. If you're able to do it, you can do it. There are other methods, analysis of CPU, and interesting like wait events analysis that became possible a few years ago, 6 years ago, and gradually developing. And it's become popular for those who came from Oracle and RDS, because RDS is a central method of SQL queries analysis. So understand where we were, in which weight it was. You can go to a higher level to see a transaction overall. It can be useful. It can be logged or in transactions. It could be ION transaction. It's analysis of performance, but not a query analysis. You can analyze statistics of tubes, see indices and tables, which updates and deletes and hot updates. I want to have it more than regular. I need to understand which tables we have. As a snapshot a minute, we can build graphs and see which tables get maximum load. But that is not exactly query analysis, although it can help with some aspects on load behavior. And finally, closer to our topic, it's a query analysis with PJ statements or logs, or there are logs that we are going to discuss today. And there is analysis of specific query, explain various variations. We need to see at various angles. And next question, when we feel there is a problem, how we analyze various aspects of behavior of query or the workload as a whole. And where is it? And that's one of the important questions today. So there's a picture of various methods. It's not full, some deviating. I just wanted to show you the scale overall of the problem. If you want to become an expert, you need to see different angles and understand. You can avoid problems different ways, but you need to find the best method suitable for you, which is going to be useful And if your team is growing, you need to describe this method and act accordingly so that there is a repeated troubleshooting, etc. So, what is seamless optimization method? We split our analysis of performance into two parts. Say we can analyze load overall as a whole, or segment it somehow while removing some parameters. Or we can say about queries of all tables, or we can make clusters and say that we look dynamically what queries can be made. These tables be related, they take part in the same query, and these other tables are not related. So we can clusterize the whole workload. We can also take the slowest query and try to optimize it, although it's not scaled up very well. Next, we look for ways after optimization when we see a problem and we want to optimize it. Could be a micro or macro level. Micro if it's about single query, and macro we can change them. And we need to look at the characteristic of this segment. Load. Microanalysis is interesting when there is specific request or we are not happy and want to make sure it's slow. We need to use explain command. There are no other options, but there are various aspects that we're going to discuss and test it. So in explain, we can make sure that there's a planner is making a mistake or the planner is not making, or we can do something with that. Or we can review the design schemes. Or in microanalysis, we can understand that something is wrong and there is a bloat. We can make auto vacuum more aggressively. It happens that we can understand it at the microanalysis level. There are pro ads. Pro ads in macroanalysis are actually similar, but they say that when we change something, we want to make sure that we didn't deteriorate others. We put outside of our analysis. That's an interesting problem, that how to make sure, and when we expedite, when once query, we don't slow down the other one. And if we go closer to the tools, and for example, analysis of PG statements, and it's open source CyberTalk monitoring, you can use it, and you see these graphs, various instruments, and put it on the screen, the requests on the screen. Or you can use GWatch or Uppercom PMM. In any case, you can construct these graphs, use other tools for payment. It's all tuned for optimization. And you can see in time this spike, a special group of queries for query ID here. And on the right, the checkup is instrument that enables, it doesn't have a good historical picture yet, it's monitoring, but it enables to feel better how it works. And here we see that based on these two snapshots, take the delta and differentiate it by two axes on time and number of queries, and we see that for this group it's 50% of time, in this case of the whole time that this Postgres operated, this server operated, and we spent so much, but per second we spend 380. It's not bad. If we don't take out the context of switches. And for each query, on average, it's about time in 10 seconds, and we need to go to micro level and optimize it. These characteristics are very important. I can tell you that you have a lot of reading, and depending on the size, and you can think and you need to have more memory, or it's not so bad. But here we see that overall there are many of them. If you make these hits 2 bytes and 1 byte, if you didn't change, it's 8 kilobytes.
So you'll see the great number, and that's for each query. So a huge number of data we send, and we return more than 1,000 per each query. So there's no limit. So we see that that's a query where there's no parameters. Yeah, I think that was old Postgres. So we see that this query has problems in itself because we return lots of lines and we wrap around lots of data. But this is the macro level. But this gives already an idea of how this query will behave. Now, as regards the micro level, we go to explain and we look at how this particular query behaves. Interestingly, and I'm going to say this time and again, then if you have a query at the macro level, you cannot go quickly to the micro level because parameters mean a lot. If you simply have select asterisks from table where column equals 1 or 0, these can be totally different implementation plans. Let's say you have 1,000,000 lines with just one digit and the rest are zeros. Postgres, knowing the statistics for such a table, will either select this index scan or select scan, depending on what value you're going to use. And this shows that we need to have examples before we go down to the micro level. But after we have them, we can go to the micro level, we look at explain buffers, and we see how it happens. And then there are various visualization tools. First, there are PF2 or Dalibo and others. Some people find it easier to read. I'm quite used to reading texts, but visualization can also be useful. So tools behave in different manners too. Overall, yeah, one more thing. These methods are perpendicular. The macro method can be used after macro analysis, but also after micro analysis. Similarly, a macro method can be used both after micro and macro analysis. But the macro method is when we cure a particular group of queries. The macro level is when you do a more aggressive auto vacuum, or you add more memory, or your disks are better, your CPU is better, your configuration has been fine-tuned. So all this affects your queries both for the better and for the worse. For instance, it can make things slower. When you add indices, this can slow things down. Now let's discuss what kind of gaps we can have. There are 3 of them. We're going to bit around them today. So gap number 1 is this transition between macro and micro analysis. Let's say we find a bad group of queries, and we would like to do explain analyze buffer. To do so, you need parameters. Where can you take these parameters? You have several options. You can take them from logs, and usually people use the video ration statement log. They cut, let's say, half a second log, half a second log, or 1 second log, or 100 milliseconds. Usually when you log everything which is longer than second, then you can have one group of results. But if a slow log is switched off totally, or your threshold is quite high, and on average it is below this threshold, and the range is slow, we don't reach the threshold, that we didn't have any examples. What can we do? So there's a problem. What can we do? Let's discuss. Problem number 2. Where can you launch your expand analyze? If it's select, then we can do this in the production environment. But maybe we didn't have the access. Maybe we'll have to ask the DBA. or this is an update, insert and delete. In this case, we can wrap around the transaction and role base to be able not to leave it. Then there's a risk of errors. You should also bear in mind that any update or delete, or update or insert, which is role-based, will leave certain tracks. After you roll back the update and insert, you will have the tuples, which is not so obvious. Sometimes you don't want to test them on your production environment. So you think you test may explain, but not to analyze. But what if you want to do a change and you want to see what if always keeps rising? In particular, in case of optimization, what if I add this index or take away this index? Then things become really complicated. There's a big gap of where you can do this optimization. And gap number 3. Let's say we understand that we need this index, or we need to take away the index, or do something at the macro level or micro level. So gap 3 is, where can we check whether this can really be released? Because we have an idea and we see on a concrete query how this helps, then still we need to check whether this is not going to break anything, this is not going to block anybody. Or a simple example, you may create index, but you forget the word concurrent. That reminds me, there's a problem. Or we can take too much time discussing things. Yes, let's do this. So overall, it's quite clear that you need to test better. So this is, I'm going to focus less on problem 3 today. I just made a presentation about problem 3, how to test changes in CI, and how to increase the automation level. My entire presentation focused on this problem number 3. So what tool do we have for macro analysis? Macro analysis, it's when we want to do this in production usually. Sometimes we don't have the releases, but we still want to do some load testing before the release. So what tools do we have? There's PG set activity. And this is quite a good source to do both a macro analysis and to close this gap number 1. Because PG stat activity, you can analyze it, you can aggregate, and we will have live examples. But the problem I keep facing in big projects, that people forget to increase this limit on query, and it's cut at to 1024 digits, and that's it. And usually we have problems with big queries, and you cannot do anything about it. So you have to increase the limit. This calls for restart, and a restart in big projects is a whole lot of events. You have to wait for months to get this restart. As a result, you go to logs, you try looking for things. Another interesting point. Sometimes they add some comments to this query to be able to track where the query comes from. And then if you add this comment to at the end, it's cut off. So they usually add the comment to the beginning to be able to shift the query, to comment that it was generated by this class, so that's open source code. And this is probably gap number 4. And a bridge to the code for programmers. It is also there, and you need to add it to the list. Now, PG stat activity has lots of interesting parameters. And in release 13, for instance, there's a parent. This backend, this line in PG stat activity is a subsidiary worker, is a daughter worker of supported worker. But I wrote wait event in a separate line. We're interested in the wait event type in particular. this is too special, too narrow. You can usually aggregate using way-to-n type. That's how sapling instruments work. You can also aggregate by application name, by client address. What else? In SQL, if you take the first word, you can aggregate by the first word. There are various options, in short. There are logs, they can also show you what's happening. There are pgstat statements. It's still standard factor. It aggregates for you. There's query ID. Unfortunately, pgstat activity doesn't have query ID. Has been discussed for a long time. There are patches, and if memory serves, things will get better. In version 14, we will be able to combine information. This is one of the ways to close the gap, as long as you increase the limit. There's a lot of information of pgstat activity, and in version 13 there's a division. For instance, total exec time is already from version 13. Previously there was total time, then there's total exec time, total plan time. And you can aggregate by various ways, and we're going to look how to do this. There are more or less there are less standard instruments. For instance, pgstat cache from Power Team. QuadStats, PG weight sampling. Furthermore, there's another candidate for replacement. It's pgstat manager from Percona, etc., etc. There are lots of tools which help you to analyze your queries. You can analyze in log yourselves, but the de facto standard is the PJ bar still. It's in parallel, but it's being developed. It is being developed, and it can understand auto-explain, had histograms, lots of interesting other things. You can also use the logs to see, for instance, the behavior of the auto-vacuum or the checkpoint. And I recommend you logging this as much as possible. I don't recommend logging all the queries in production, but the behavioral auto-vacuum, maybe all of them, or at least 1 second worth of work. This can be quite useful to see. You can see blocked queries, for instance, when the deadlocked timeout. Despite the name, it has a different role. Usually, after 1 second time, the blocked query will be logged, and you will see both the backend log, the one that has been blocked, and who blocked it, with the parameters, which is quite useful. And query withdrawal, pgstat statement. If the query was too long, it is not logged in pgstat statements. This is a problem which people are trying to solve. Yandex has got a similar application which shows errors but will not show you any queries. It will only show types of errors. But overall, you can see in logs queries which were cancelled. And this is useful, because without logs it is quite difficult to still to live in a big project. pgstat activity, pgstat statements I've covered. This is the old version. This is total time, total exact time, but there's a lot, and it keeps growing. pgstat statement, exact time and plan time are now divided in Postgres 13. There are only 8 metrics now. It is useful to see various aspects here, not only total time, clearly. There's also information about failures. And I keep saying about query groups, not just queries. A query group, query group, if you use it, you can understand which query group generates more val data. If you take 2 snapshots, you look at them, you see that 50% of is generated by particular query groups. This is the reason to start thinking, because lots of vals means lots of backups, slower recovery, and replicas also have to do more. So pgstat cache, when we see the shared buffers hits, they can come from memory. I see that many monitorings keep repeating this memory. They call these discrete. They are not discrete. They share block hit. So from the page cache to the buffer. From the file cache, this goes to the buffer. But this is a hit. This can be a hit for this cache. It may be a hit, maybe it isn't. If I need to do it quicker, please let me know. I can do it quicker. So, what we see that we don't get everything we need to see. We don't see how well the file cache works. This is important because roughly, if the difference is of 3 orders of magnitude, disks are quick, so is memory, but still if the difference is 3 orders of magnitude, then you do a hit 1,000 times and it's 1 read. And these queries affect as if there were many reads. And it is all cached in the core, and there's no problem with the disk. pgstat cache helps you to see real disk rows and to see what queries result in reading from disk. This tool also shows you to analyze where join filters and to see how filters behave. This is an even more exotic expansion to Postgres. It helps you helps forkload to analyze the behavior of predicators. PG weight sampling, another good thing. There's PG sampling and PG weight sampling. They both have pros and cons. Both of them help to see and to analyze, to expand PG state statements based on the weight events and PG stat activity. So you need to see which is more applicable in your case. I forget the precise information. So one of them shows concrete examples, the other doesn't. And there are some minor differences too. So if you want to have performance insight, you need to select the RDS. You need to see whether you need to see particular examples or not. Check the parameters. There is also this ad hoc tool, which you need PG top and PG center. And PG top loses a lot to PG against PG center. A new version appeared a short time ago. PG Center can do a lot. We had a major session at Root Postgres. We didn't even cover all that PG Center can do. So it's a cool tool which can show you both the top, a snapshot of the top, but it can also do sampling. It can do weight event sampling, among other things. So as regards weight event sampling, RDS have been promoting this approach because the guys from Oracle need it. And you can see these colorful pictures in Aurora and in RDS, both for MySQL and for Postgres. But when I was preparing this presentation for PGConf, I wasn't convinced that this is something that they need. But then, after that, I had a number of cases when GPC statement and PG stat cache couldn't cope. Analyzing weight event helped us to understand what the problem was. In particular, about high frequency events when problems occur with locks or problems with buffer pool, network problems. So you can see a lot of interesting things here, but there's a limitation too. Because if we look at the y-axis, it's the active sessions. It's the so-called active session history or active session analysis. So we measure in backend units. It's a quite a bit of a perpendicular approach to BGStats tickets. And here we do sampling.
Once a time, and we show active backends. But the practice shows that it's enough in loaded system. If you look at many samples, then you can really see what the problem is, and you can see the spikes and the reasons. This picture from RDS, not everyone on RDS, and I found out about this tool during our community streams on YouTube and on Zoom with Postgres, and it's called Ash Viewer, Pash Viewer. Pash Viewer, that's what I use. That's a Java application that does the same. You connect it to your database and start looking. Overall, it's good. I recommend to immediately turn on. It tries explain by default, and then you have cut queries and you have errors. So better turn it off. It's in settings, but overall it's a good thing. Green is CPU, and here is more CPU bound load, and we see the group of queries. It takes BGS activity and aggregates. It's macro analysis, and we can see that group of queries, some parameters were off, and it was sitting in CPU or in IOs. We don't know whether it's disk or not. Maybe it's so much memory, it's overall too much, or we were locked somehow, or the client slowly read it. So it's a useful tool, and you can take it and turn it off, but it's ad hoc. But what if the problem happened 2 hours ago and not repeating? So here it's better PG with sampling or PG Sentinel, and this Ash view is supposed, while it's not in monitoring, you can put PG Sentinel. I test it on your loads, and then it will automatically understand that it's installed and write it historically, which is useful. Of course, best to put this information in monitoring. Any questions, Artyom? That's it. So far, no questions or comments. It's all good in terms of speed, and people are interested in details. Excellent, because sometimes I hurry up. Good. So, interesting moment. Pash view integrated with Sentinel. More Mac that Sentinel developer works in Word, and I cannot say that 100% that RDS Performance Insights is built on the same code, but there's a hint that's some connection here. French people who develop on monitoring is very interesting with very bad interface, though. We discussed certain monitorings on Postgres a year ago. We had a few sessions. I advise you see on YouTube, and they selected Postgres Pro sampling and put it in their monitoring. So you can get understanding where it's happening. But here I don't see queries, but there are queries. Are always issues with this interface, but they think interestingly, and they have something nobody else has. It's an interesting product of open source monitor. Let's make a second step. I made the first one. We look at PGS activity, have certain background workload, which is generated on BGBand. There's some workload, and we can look at PGS activity with a snapshot of it and understand what's happening overall. I suspect this is small virtual and it's overkill when I was reading my speech. It's a simple rule. Some caveats. If you have 16 cores and you see 16 actives, it's time to think about it. So we cannot simultaneously perform 16 queries. Okay, we can do on 16 cores, but load average will grow. You don't want it. It shouldn't be more than a number of cores. But there are caveats. Because active, we don't know, actually. If we look at the state, we don't know whether active is really done, or maybe it's I/O away, or maybe we are locked and waiting for some lock, and we just wait. And if we wait, so it's going to be active also. It's not necessarily a CPU. Maybe CPU is not expanded much, but the rule is that if you see active exceeding the number of cores, it's the reason to think about it. But how to understand, how to separate whether CPU or not CPU, or disk IO, or we are locked and wait when we can, or someone put this lock and doesn't release it. We see it here. It's a different lock. It's a buffer pool work, but there was some I/O at the moment, but activity. Okay, we don't have enough detailization, by the way, and we can repeat it. I'll look at another snapshot. It's work with buffer pool. Nothing more interesting. Little information, so it's not comfortable to catch it at the moment. So let's look at another pool, see how PG Center does refresh. And here you will see PG Center requires a wide screen. As a developer of PG Center, as one of the examples where some tool which is very useful is developed by one person and some fixes are done. So thanks a lot to Mr. Lisovsky for that. It requires a wide screen, so sorry I reduced it. But we see we have some reading, work with buffer pool. Oh, that's how it is, but no locks. Nobody interferes. So it's once a second there's a refresh, and Q, Control C is to exit. I lost my focus. I need to click and press Q. So we looked how we can do ad hoc analysis without aggregating to see live with PG Center. So before we move to the third step, don't do it. We look at the presentation, listen to me. So let's go to the next one. It's all interesting, but what if we want to aggregate somehow to make it out of the box? We can look at it differently. So first, PG statements will not be enough. But to make reset and then do it manually and on a daily basis is possible, but ZA do it. But in a highly loaded projects, I suggest to make resets less frequently because there is a problem with statements. Certain latch can slow down even regular selects, and if it's all integrated in monitoring. So I came up some snapshotting and working with deltas. It's a good tool. Could be exporter or Postgres checkup that or PG watch. But you need someone take 2 snapshots, certain breaks of several seconds, and calculate the deltas. Standard deviation doesn't make sense without deltas. So first method that we can say, so what are your goals of your macro analysis? It's important to understand your goals. If you don't understand your goals, you'll have untimed methods doing whatever they do. Like first goal, we want to grow and reduce the load on resources. So first you need to start with total execution time, because this shows which groups of queries take most time for execution, and the server is busy with this queries most of all. But that's not the only goal. It could be other goal. For example, could be a situation where total execution time is not large, but the number of costs is so much that the context of switches like 10,000 times a second. By the way, select one or select as a minimal query that can be sent. Point comma could be for health check. And some suffer, need to straighten it out and need to act differently. We can discuss it. But for the purpose to understand this, whether this master server is live or it's time to go to replica, whether we take other replica, so okay, are we in order? Is it okay? Are we in line? Yes. There's situation that have a lot of calls, but in total time you don't see it in top 100. We had this situation where I'm in 200 place for total time and queries that makes 3,000 times per second. And it turns out that, by the way, select one, it's not a big problem. For Postgres itself, it's not a problem. It could be a problem. Need to look specific situations. And here, you might go back to event analysis and to see the contribution for CPU load for this group of queries. But you might have a situation where the base is done on select one, it's a separate transaction, and PG bouncer, and you 100% know that you need to launch several PG bouncers, like 10,000 transactions, and this range on the modern hardware, one core, one flow of PG bouncer shoots, and it all fails, and you need to reduce the number of calls. And sometimes it happens, the situation where you're in 100 place for total, but first time on calls. So turns out to process output of this select, you have to have more applications, node, and the load from the application starts. And so having reduced the frequency, we can less machine Python applications. So not always think about base, but think about others, how to administer applications. Maybe you make a gift to them and say, and we'll have feedback, because it could be easier for us for pull connections, maintaining, and so are interesting aspects. So there's a question. Well, we're not far about increasing track activity. Doesn't it bring to additional overhead? And what's overhead? PGS activity is a piece of memory which is there. You can analyze it and see how many MPGS activity records and how many bytes you will increase this expenses, and you will find out that you can easily do it up to 10,000. But I recommend to have some doubts, especially in optimization, especially if you want to increase buffers up to 60%. Could be good recommendation, could be bad. So you should always have some doubts and experiment. Our approach, Postgres, they're all experiments. And you need to calculate in your specific case, and you can look actually what happens, etc. But it's a good question. I was concerned also, but I think we can increase up to 10,000 easily. So, for another aspect which is interesting, as a mean, it could be max. Depends what application you have. To look at the mean time. Could be good for total time, but could be queries which are rare, not seen, for frequency, for costs, and want to see in the unit of time. We take max or mean, two options. It could be mean so bad for some group that they are rare. That's why they are not visible, not in total, not in calls. But the users suffer. Could be some employees of your company. This piece works slowly, so you need to take a look if you worry about users. So use of resources unlikely to improve it, but the user experience will help improve it. But max exact time could be if we are more analytical and we have slow queries at stake, slow queries, like go from 30 minutes to 10 minutes, 5 minutes, then we need to look at max. And specific thing is planning time. If you want to have more statistics and default statistics and or for specific columns, and when you make this exercise and total planning time and mean time, etc., it's a new thing. And honestly, I haven't felt it in production because there's no 13 Postgres yet. I need to understand it. And finally, working with the volume of data that we work on, heats and leads. It's interesting that after I made this slide recently, we had a situation where these rows, you need to see, have not so many rows compared to heats, and the buffer is working well. Could be a large database, but the buffer pool is 10 times less, but there are less rows here, mostly heats. You can take a look at the database, so the working volume is in the buffer pool, but it happens different way. You can have many rows, but it doesn't mean there is a problem. It's a level higher. Postgres doesn't see it. We need to see cache and need to think about it. The cache can help. It could be an interesting situation when the spike for the whole server is so bad and CPU is up to 100%. And it turns out there are some queries that make so many hits from buffer pool that don't need to be analyzed. But the analysis for PG statements of the spikes is unbelievable. It's a huge frequency of requests and could need to analyze spikes as well by hits or buffer pool. So all metrics are good and useful depending on the situation. But some are needed more often. So how to analyze it? And that's our example. It's a deep analysis for 2 snapshots. We look at deltas, we calculate them, we differentiate by seconds, number of calls. So 1, we have second per second here, many milliseconds it takes to perform this query. That includes also wait time to get log. And in the end, in this group, we show a percentage. Here is extreme situation. This request is almost 100% of the whole timing. But at the same time, only 2% of rows, but 100% of hits. We hit them all the time. Here is like 20%, and we use them by this update. So you can meditate with this, and with time you start to understand this group of queries. You don't need to go to micro level, and all the queries are good. You don't need the index, it will not help. Just go to application, or you see it's obvious that it's 2 times per second, but on average the query is more than 3 seconds, so optimization is needed. So index is not enough or something. And 2 snapshots. First, line delta. Second is we differentiate it. We take a derivative in time, a second for calls. Divide by the number of requests. Third, how large we can write a pie chart for hits and see that this query is almost 100%. So we go at a higher level. It's not useful for all. If we have many functions, it won't be useful, but if you have ORM or Django, all requests are select update, and you can aggregate it for the first step.
So Postgres checkup does this, and you can see that selective total time. So it's at a higher level. You start feeling it better, and you can go another level higher. But you should bear in mind what the statements the dot max. If it's too small, then it's not too good. If your query keeps flowing, and then this is not good. So we try highlighting this problem. But if your pitch estimate is big, like 5,000 or so, then most probably this volatility will not be that big. And at this highest level, you will be able to understand your load. How much is total time? 8 seconds per second. If it's 8 curve, then it shows that it's enough already. And it's already bad problems. You don't even have to look any further. We also have checklist monitoring. What you need to do about the monitoring. We created this half a year ago. The alternative to PG stat statement from Percona, as that also was from. That was visiting us the other day. He told us about this PGStat mentor and why they made an alternative to what was not there in PGStat statements. I'm not going to repeat myself, but I took out, I left only the lines which differ. First is you can aggregate by application or by address or by relation. There's a whole array of data. Analysis of erroneous queries. You can take the error code to understand where the error was or in the counter. But again, there are no concrete requests. Only these metrics which keep increasing, or depending on the object array. This is the link for details. If you already don't have enough PGStat statements, then the time is up to look at the monitor. Microanalysis. I think that we need to. I'm afraid that we can lose our machine if we go on like this. And we'll have to bootstrap again. So let's discuss microanalysis now. Explain is the main tool for microanalysis. Let's say you have a concrete parameters for this query, and you want to understand what's inside, what's going wrong. Explain will only show you what planner promised to do. But you're able to delve inside, you need to do explain analyze. I recommend to use this with the buffers option. We even had this discussion. I even submitted a patch to make it default in Postgres 13. Maybe it'll be default later on. Interestingly, the default timing, although I would switch off the timing, you don't need to see timing in every press because it's quite volatile, depending on the cache or another state. Or let's say you can, something is locked. The amount of the volume of data will be similar if you're doing this on a copy or in production. If it's selected, then you can do this in production. Your buffers will be fixed. The amount of data will be the same. If you have logic copy, if you had to do this for some reason, then you can look at rows instead of buffers. There was an interesting discussion in spatial chat. So, the adaptive query optimizer, for instance, it works on rows. The question was whether you could work in buffers. But in any case, to understand the plan, you need to have a benchmark. And time is the end, the target, right? But if you start digging into the time, so you should better look at the amount of data, either rows or buffers. Buffers is better, because it's a physical feature. Because there's a lot of bloat, even at the micro level. And furthermore, there's the number of other parameters generated with Postgres 13. I encourage everybody to look into buffers. We talked to T. Beaver from Postgres, and I was quite surprised to see this method. But I still am convinced that this is much better than to look at timing. Timing is overestimated, buffers is underestimated. Furthermore, timing has got a lot of overheads. This is an article on Postgres, and shows very well that some machines, when it checks the timing in every node, it was up to 8 times slower. It depends on the machine you have. So you don't need timing. Buffers also have overheads. We're going to check it to measure something, but their overhead is much lower. I would even say buffers on, timing off, in particular in the production environment, because you don't need any overhead there. Now, this is an example of how time can drag on. So its select time is 8 milliseconds, and when we analyze it, it's 19 milliseconds, which is more than 2 times longer. It's just because we internally check our time, measure our time. So this is the article. As regards visualization, there's a PGAdmin, but I'm going to skip it right away because it makes me nauseous a bit. There are de facto standards. DBHCOM is still quite well spread. It's an excellent version. It makes you compare colors. There's another interesting thing which has been promoted by one person. It helps people to find their way, although I don't like this color-based approach. We cannot say whether this is for 5 times redder, but if it's for 5 times wider, let's say flame graphs. We did it. Somebody added the PG flame. This helps you to see that, but the times are the buffers. But buffers doesn't look so well. But you can see the scale, right? The daily boat was made in a similar fashion. Postgres post-screen visualizer. They did PIF did. I think minimap is even more important than the main picture on the right-hand side. If you go to buffers, you will see in the scale what buffers when we start working with lots of data. Why is buffers important? Let's say we want to look at one line, 25 lines, 100 lines, but we don't want to with all the data. The entire purpose of DBMS indices, smart indices, that the purpose is to look into as few memory pages as possible, just to have a look at one line, 25 lines. If you have to dig through thousands, maybe dozens of thousands of lines, each of them is 8 kilobytes, then you have a problem. You need to analyze and to optimize the indices. This is why it is important to look at buffers, because timing is volatile. Explain tensor has been developing quite interestingly. I haven't seen all the reports about it, but I've seen new things appearing. This is an old screenshot, but I encourage you to look. My Russian-speaking listeners know this. There's lots of articles on hammer.com about it. Lots of interesting and very unusual ideas. Unfortunately, in Russian only, because these articles could enjoy a larger audience in the English language. PGStat. We're going to announce this. We're going to host Michael Christophidis this Thursday. This is an SAS tool. It not only visualizes, it also helps tries ranking problems. 5 stars, 3-star problems. So where is the highest chance you get something? So it highlights the problem and then shows how to improve it. Let's make steps 3 and 4 finally. Right, very well. Right. I keep on moving. It will take some minutes to warm up, and then I will start repeating things again. So, let's discuss before it warms up. And then we'll get all the way to step number 9. So all our steps are already well tuned. So let's discuss the first gap. The first of 3 we discussed. How can you switch from micro to macro? There's the anti-method guessing. And if you're an experienced DBA, you can look at the distribution in the table. Sometimes I forgot to look at the distribution in the table. Select column, the dollar equals. How can you have a look at the plan? There's no way you can look at it at the logs. The activity is also truncated. 0 and 1, true and false. I take the worst case. I know the distribution, I take the worst case. And then I see that it is never used at all. So you have to make a partial index. So guessing is an anti-method. And this is something I would like to fight against. And I do fight against it using various experiments and automation. And 100% methods, which rely on any guesses or black magic or like 10 years of experience, etc. I see a question in the chat, explain tensor. Right, I just mentioned it. My screenshot is not the most updated version, but if it were in English, that would be just perfect. So guessing is the wrong method. It is still used and it is dangerous. If you know statistics, you can guess better, but qual stats, you cannot really understand what is used, and you can model a bad situation, and then it will happen. Right. PGStat activity. Increase the activity query size track. You can look at the logs. Yes, we discussed it. If you use auto statement, you can use duration log. And the question is whether you need to switch on buffers and timing. By default, both are off, and this is good because there's a great overhead in the cloud. Maybe you don't want either of them, or you would like to have any buffers. Maybe you don't need anything. You just need to know the structure to log auto-explain. And you need just to know the general duration. Maybe this is the right thing to do. But you need parameters. Where else can you get them? It appeared in Postgres 12. It improved in Postgres 13. At the transaction level, I begged the author to do so, and so he did. I would like to thank him for this. So either at the query level or at the transaction level, you say, we want to log in just 1% of all the queries, or a percent of transactions. You can do this at the core level, or at the auto-explain extension level. If you want to see plans in the logs, for instance, then you can take this 1%. I would encourage you using the transaction level, because then you will see the link, the whole chain of transactions. Furthermore, there's a prospect. You can take this load and you can accelerate it 100 times, and you can start playing with it. But this is a different topic. So basically, this is it. Increase the active query size, look at the stats. Another interesting point. Attempts have been made. There are extensions which are not used anymore. Hitty did this, if memory serves, but then they abandoned this. Postgres Pro have got something which includes samples of queries and plans. There's another approach. It's highlighted in amber on the right-hand side. You can take pgstat statements with parameters and feed it into pgquery library by Fiddle, the co-author of SAS. You can upload this into this library, and you can get a fingerprint. It's an analog of 3ID, only it's a smarter one. And you can apply it to what you see in the pgstat activity or in the logs. You can use this query. It's also available in Ruby, in Go, in Python. So various wraps. But overall, it uses the same code as the Postgres parser to build a tree. And to get this fingerprint, you don't need the tree in this case. You may use it in other cases, but you can take the fingerprint. You can see what you can see in the logs and what you have in pgstat statements, and it works. Or you take it from pgstat activities, unless anything's truncated. So let's go to the practical part. So we have pgstat statements. Any questions so far? Because it will take us a couple of minutes to warm these things up. I had to use Ubuntu. So, colleagues, what do you... Anybody has got any problems with optimization? Any issues? Artyom, any questions? Looks like people don't have any problems. Or is everybody fast asleep? Or maybe people started looking into these tools and problems. Another interesting point I would like to discuss. We're going to continue we're going to repeat the previous report, and we will tell you that you need to experiment with clones, either thick clones or thin clones. Now, there's this issue. If you experiment with a clone, it differs from production. It can differ from production. It will differ from production. With respect to cache, the timing will definitely be different. Furthermore, it can differ in terms of resources. Disks can be weaker, or the file system can be different. The file system is usually the TFS with thin clones. So your timing will always be different in this respect. This is why we do our best to get the new tool, which it is hard to get, but we have already progressed. We need the statistics for web protection. We know how this behavior in a lab looks. We would like to forecast the time. We would like to forecast the time. We know how difficult this is, but we're still going there because we know that we need it a lot.
So something is very slow. Well, those who influence the final result and the range is possible to build, but often it's so broad. Yeah, with a large reserve. And main difficulties in this is for this range to reduce. Yes, we resolved many issues where one issue unresolved, when we see many hits in execution, to turn it into reads, it's a big task. If you see 1,000 hits, you might have 100 buffers that are read to understand that it's 100 buffers and not 1,000. It's unresolved issue so far. And we temporarily defer it, and we turn all these hits to rows, and the top range is higher. But it's good, because we worked out the lower level better. And Kotokot optimized 70 megabyte. It's a sad picture. We'll not use it anymore. So it's an interesting issue. What's up in the chat? Let's say it's all good. Presentation was good. So containers are working. Okay, the low 3K per minute. It's not much. Sampling went to reduction. I haven't experienced it. Need diagnostics. Well, someone encountered that. I remember it was mentioned on the stream. Yes, it can happen. I had a different story with a different extension. And I mentioned GFAC stake. I'll tell you a scary story. Was tuned auto refresh of the system, and all packages were excluded for upgrades to do manually, and forgot about this PGS, and there were no releases. But suddenly there was a minor upgrade and release, and we had some faults. We need to collect the cork and half day of the work. But it rectified fast. Sometimes extensions should be used carefully. We haven't created a base yet. Okay, PG statements, need to wait 1 minute. So we understand that less popular extensions means that more probability of some issues, starting from so-called observer effect, when we just measure and we slow down the system. If you make it to 0, in several tens of times, you can get a worse, like have less TPS. So you can't do it so drastically for all curious aggregations, starting from observer effect and up to faults of everything. Right. Unfortunately, these extensions suffer this problem. So we can use zero install tool, Postgres checkup, and witness sampling. That's it's like from PG activity, and don't install anything. It's not possible because the client is large and it's hard to approve. I haven't counted many times. They say they want to remove extension and use what's available. So any changes in the core is very good. You can see an avalanche of information. So technical issues are still with us. Virtual is very slow. Well, it's 3-4 minutes to start, as I observed. Yeah, couple of cores. Well, thanks for 2 and not 1. Postgres already operating. Okay, I will wait another minute. So the second gap is where you check how it works. And that's the first step. Only you reproduce the problem so that to optimize, you can reproduce it. You need a good environment, clone. Those on RDS and other Postgres, Yandex Cloud, all Heroku digital option, good because they can ask for a clone. And on RDS there's still lazy load problem, but then you will warm it up for an hour or more. Yeah, but just also in. So that means there's a way to clone it with clouds and get a replica and promote it, and depending on implementation, you can experiment. You can warm it up, although with buffers don't need to warm up. I exaggerate, but still. Excellent. We can start. So I need to click to change the focus. Now we're seeing PGS activity. PGS Center is also running. It's all working. So third step is macro analysis. So first we want for total time of execution, get top 5 groups of queries. And I call my groups. One we remove parameters, and the other one aggregated in initial course is called normalized query. So let's try to connect to PSQL, demo on base, and execute this query. We see top 5 large. The database is the same. It's not interesting. It's aggregated query. New versions, and we see that for total time, let me fix it. Meta fix 3. Okay, we'll fix it, and we see that there's a show that more than 90% PG statements starting from reset time. We don't know when reset. It doesn't remember. I think the 14 Postgres was committed. It will remember. Otherwise, we had to reset other statistics, usually in memory, and get this time from there. But that's a life hack due to it's a problem, but less curious than others. These are 300, and I'll select this 38, so we execute less of them. It's a question because clients ask not so many, or we don't have time. We see saturation. It's probably we cannot cope with a larger number of queries. Some basis to understand where is the problem we can see in heat and read. We do a lot of read for this query. Other good article why selects could lead to reads. And now there's a new information about faults. It's encoded with wall records, so we need to understand how much memory is consumed by specific queries. It's a very complicated issue. I think it's published a few articles by Microsoft, but it's a team, how they're called, did sharding. It's out of my head. Citus was purchased by Microsoft and in Citus blog, and was duplicated in Microsoft blog, and in a personal blog I posted. They detailed like Postgres backend memory consumption. If you are interested, I advise you to read these cycles of articles to understand, and after that you will not ask these questions, because there are so many aspects of this issue in Linux, and Linux is complicated to how much memory is taken for a specific process. So I cannot tell you out of my head which tools could be best. So indirectly we can understand if work mem is not enough. We'll see stem bulks written, so memory is not enough. You see it by queries and database. In logs you'll see specific examples with parameters. If logging is on, I advise to turn it on. And Postgres enlightens there's a problem, and then we can segment these issues. But for memory consumption, please read the articles. Now, we see it's a large volume of data here. So how can we optimize it? It was live, I would ask you, but I say I would look first why we have such a large volume, especially rows, and if we divide this number by the number of calls, and not so many calls, and then multiply by 8 bytes, and we'll get it in bytes. For each query, on average, we'll get the answer. So I started doing it in order to reduce our sufferings. And next, about this gap, we discussed the options to close this gap, logs, PG activities, etc. I'm sure in Postgres there will be something more seamless, but so far we need to improve it with PG query, as fingerprint, and glue it from PGS activity and PGS statements. Let's say we found some parameter. For example, Citus, is the chat slow? Like we found some parameter, a specific example of query. like we're interested in this value. Let's see explain. We have explain without execution, and we see that the cost is measured, but overall it's a large cost that we expect one row. That's what planner thinks what he's going to do, and that's what he will think about each node. But we see this post is formed on this leaf node, and it's a tree. We see it's scan, and we expect to extract many rows. Well, count is a count, too many rows, and it's difficult and it's heavy for this database. So let's try to execute it. It will probably take time. I will see in attributes and macro analysis. If it's our production, then overall it's good. It's not so much damage, although we can kill cache with these actions. Many negative aspects here of making microanalysis. We are not considering clones. It's a separate topic, separate training. I'll tell you the time later. And we see when one row is back as promised, and probably no mistake. 20,000 was gonna happen, but here it starts so to have a problem, and rows expected. An actual is a serious mistake, and those who know plan rows moved, it's an attributable problem. So buffers can be multiplied by 8 kibibyte and get and understand what's the volume of data we had to use to return one number. So the problem is that many rows are removed, but you need to scan it all. So the query and microanalysis shows that the query takes time. As it's obvious, is need to create an index. Let's create the index. It's a trick here. Index for column would not work because in our query, with one of the could be less or more, not equal. We have transformation to date. We need to build the index, so-called functional on expression. Functional is wrong. Better by expression. On this slow machine, it will take time. So the example is trivial, and I just wanted to show you so that you can feel this gap. If you want to scale up processes in the organization, you need to remove this gap. Like if you're great and you optimize, but you need to grow to build DBA team, you have a lot of databases, you want to document it for developers to do it themselves. So this gap should be removed inevitably, and here are two gaps. First example that we took, and it turned out to be a real problem. And second, roughly we experimented on production, and the worst that we check index on production. If we were in the room, I would have asked you who have made the index to circumvent the control version system. But first it needs to be done in lab conditions on thick or thin clones. Okay, we made index. It's a small remark, a nuance. If it was index for one column, it would have been good. Then we have statistics on a column. Since it's an expression, Postgres doesn't have statistics of expression because we can wait for auto vacuum to make it, but better to take it under control and redo statistics as Postgres sees that there is index of expression. and it will collect statistics on this index, and it's good. Only after that we can start analyze. Let's go back to macro level and write off statistics, picture statement, then see how our new statistics look like. We should have waited more, probably. Need to click to operate left and right. Calls not so many. Let's see. And picture statement has a thing that in the beginning, and it's an issue of security, at first we see values where statistics is put on for a specific example of query. There is no normalization. Although it's interesting, I haven't felt it, but that 13 Postgres is not production number of plans can hint us that how many examples we need to find of queries when we go from macro to micro. Like we see one and we know for sure statistics was collected for many days, and we see one, we want to optimize it, and we see two, we need two examples.
This is quite interesting. You can even reflect it in monitoring one way or another. I'd like to thank those who did this, because this improves these usability tools a lot. So let's have another look. We still have this value, and it's 0 in the plan. I keep talking about plans, and still it's a 0. And we can also see that there are still too many rows. We still have, let's look what we did in the beginning. So we have this query, and you can see that it loses a lot against other queries in terms of frequency. So the question is whether the client is asking for less, or most probably we didn't have enough capacity. Tutor time is too long, 90% like. And interestingly, the range between min and max is too big too. Sometimes it takes no time, and here we had to wait for 28 seconds. You can see that there are too many queries. If you divide it by calls, you will get too many rows. Something's wrong. And the answer is quite clear. We selected the bad example. We stepped over gap 1 in the wrong way. We found the wrong parameter. We took a wrong example, not the one that optimization asked for. So let's give another try. Let's analyze it another time. We can see this plan with the value which I have already used. We can see that things are now fine and dandy. It looks so beautiful. It's not only in the cost, but also in the actual time. Under 1 millisecond, 24 microseconds. The index works well. All is fine. But then there's this query as well. So we change parameters, and we see that this is the same group of queries. If we normalize it, we will get the same time, $1 and $1. But by simply changing the value, we get a totally different picture, and this makes us think a lot. There are 2 different plans. There's a big trouble underway. 21 seconds, and a lot of data had to be used. Previously, we would hit in the 3 buffers, 3 times 8 with 24 kilobytes. It's up to 1 gigabyte. I usually do as follows. Programmers need to transfer to recount buffers into bytes, and then you will see that this transparency helps you a lot. You can divide 8 by 1000. half a gigabyte. Half a gigabyte. They're based on megabytes. So, which means that we have too much, and these are just rows, to say nothing of hits. So, a huge amount of data. Well, it's quite clear this has a reason for it. There are so many lines there, but then there's this rows removed as well, and we have to think what to do about it. We built this index using the m time and the mbit. Now, if we take a different value, we see that we get safe scan. Why cannot Postgres do the way we wanted to do? This delay prevents us from real-time communication. You could have a look at like post. Maybe look further, but in any case, even if we do make index scan, this is off as usual. If we segment it, then things will be bad anyway. The answer is simple. There are too many lines. We have to count too many lines to be able to get the real value. This is inevitable. So, in this case, Postgres can scan index only, which will not touch the kip, and have a very strong auto vacuum to be very up to date, and to try working at that level. But overall, the story is that maybe you don't need this data at all. Maybe you need to clean it, or maybe to store it somewhere, or to package it. You can do this using timescale in a much more automated fashion. If we do truncate now, well, the thing is that this background load generates data, but we had a big amount of data which we didn't need even before that. So there's already something in the table, but yes, the data is being generated, new lines are being generated, but this big legacy of data is now gone. Our optimization. So let's imagine this data is in the past. We simply vacuumed it. We need to partition. We simply drop out partitions. We previously aggregate, save the aggregate information. And clearly, time scale would be an interesting thing to look at. And then what we do, all is well now. We had random selects previously. The select is too slow. So we consider the call select is already even now. We drop the partition with the old data. We simply start partitioning here. We didn't even touch the old data at all. We see that we've been able to solve this issue. It's a workaround. Index cannot solve all problems. Sometimes you need to use other tools. And you can see this select right away. Right, it's down there. It's now the quickest possible way, and the min max is now 7 or 8 milliseconds. Yeah, it's quick now. So we'll have relieved the load. and things look much better now. The load average is also down, the expectation is low. So basically, this is quite a illustrative example. And let's say when you decide to do this truncate, then you need to test it. And this is a long story in itself, how to release it. In my previous report, I told you in particular about this third gap, how to test changes, how to make sure that nothing has broken. And the answer is you should use clones, in particular thin clones. And last but not least, an interesting tool. Caused a lot of interest in the past. Artem developed it. It's Plan Export. It's a small tool which helps us to visualize right from PSQL. So we have a plan, but we send it somewhere. And we need to tell the system, catch Y, and the plan has just been sent to, and we can have a look at it. It was just pushed here, and here's our plan visualized right from PSQL. Some may find it useful, or we can switch. I think you need to press Ctrl-C to exit this. So we can switch over to Dalibor. And we send it to Dalibor. Yes, there's Ctrl-C. That's right. I use Ctrl-C. Right. Catch. So we're in Dalibor. It's a similar plan, a repeated plan for the same request, same query. So let's see. So this is the same plan. You can see how it all worked. So this is what we see. That was step 9. And step 10 is about thin clones. It's a separate topic, separate tutorial. And we had 2 interesting streams on the group Postgres community. YouTube/group Postgres. And you can see there how to work with thin clones. You can try deploying it, auto working in Slack. With the bottom that will issue the thin clone. There'll be 1 terabyte databases, and you can work with them right now. So basically, overall, I'm almost done. Let's get back to slides to finalize and to wrap it up. The pagination tool. What's the name? The name is PSPG. PSPG is the name of the tool. 4 letters. It's available. And you need to see there how to switch between various PSPG and the less. And there's the F button. You can support export. Pavel Stachel did a great job in this respect. You know, I think he did it after I launched the Postgres DB Interactive. He said, yes, I can show you a whole menu there. So you can have a look here as well. Well, yes, you can have a look. Yeah, we forgot to update to Postgres 13. So, PSPG. Let's wrap it up with the slides, and then we'll start answering questions. All right. Yeah. You better do this on the clone, not on the production version. Another topic which we did not touch today is to how to analyze. Yes, like I said, maybe we need to work for logs. Log analysis is a serious topic because it pushes us from the query level to the transaction level. Because logs are relieved at the end of a transaction, after a rollback or a commit. If you capture a log in the beginning, you will not be able to release it until the transaction is over. So this is why small transactions are important, because it's better to get rid of logs as much as possible and to start working with heavy transactions at the end. To analyze logs, you can use this good query. You can look at it. You can look at the snippet. I think this goes from the Avito data aggregate. But I worked on it to be able to see who logs whom. This will give you not just a tree of blockings, because if you're blocked, you can block someone, which is sad because it's a whole tree. No, it gives you a whole forest of trees, because when a problem appears, quite often you get a number of trees of this kind. And you can execute this query once every 5 seconds, once every second. And this forest of trees is very bad, because ideally there's nothing you should see. Sampling can also give an idea that you have this problem with logs, what particular queries suffer. So thin clones, it is a way to diagnose and to check before deploy, to test your changes. We can also see, in case you haven't seen, we can show you how we work with thin clones in this interface with the chatbot. When we have no access to data, but we can see the query plans on real data in a thin clone. So this is a demo project. There's a database lab engine instance. It has got a 1 terabyte base, production base. 1 terabyte sample production. We supported in the latest version. We work with the fresh data, which cannot be more than 1 hour old. So, what is important to understand here is how you can get rid of gap type 2 totally, even if the developer has no access to data. But the question is, what the production plan will be like. All you need to do is to write a code. PG bench accounts equals 1. It will be a very quick query. It sends the query to bot. The bot makes a 1 clone of a base. 1 terabyte base was cloned in 1 second. First, it makes a usual plan, then a plan with execution. And we can see that the actual time is 3 seconds. Please bear in mind that the timing in the lab can differ for the worse. But if we look here, you see that we have just 5 buffers. This is not many. 5 times 8 kilobyte. And if we try capturing more data at a certain interval, let's say 10,000, right? So we need to take even more. Oh, I'm working with a small database. But you can see already, we used a new mechanism. We have this problem, how to predict from a lab the timing. Artyom, correct me if I'm wrong. Yes, if we have enough samples, then the value will be different. Yes, weight event sampling. We can see that more than half of the time we spend on reading. The other half is spent on work. In this case, in the execution, we see half a second in the lab, and we see half of a quarter of a second production. And most probably this is correct.
If statistics is fresh, it should be accurate. It's a new feature which we wanted. For example, to understand how we can create this index, whether it's within the limit. We might have some standards if we have large organization and the release is more than n minutes, need other approvals. Or more important problem, if you want some complicated DML, you want updates we want to cut it for batches, you want small transactions, not to exceed 1-2 seconds for execution. I have a question how to select the batch size. So with the help of this estimator, on real data you can fill various intervals. Well, you still need access, and so it's possible to make it more comfortable, to make a chain of requests queries automatically or connect with clone directly if you have access. But it's important that you will see part of estimate is with Jaw. It will go to core engine and it will be visible in the chain of queries sooner or later. It's a matter of time. And then we have visualization and various ways attach photographs. And it all goes to history. You can share it with team members and even make it public if you want help from outside. So that I have this plan and this visualization, it's all internal. It's a protected environment. Only your organization can see you. So this is seamless. Second gap is removed with this tool. There are many nuances. One thing is to discuss, and the other thing is see how to use it. We have good experience. We have several engineers, and we encountered many things. But it's cool to see when people say it's magic, and they understand how it works without asking my DBA. And DBA say that don't need to wait for clones. You just request that it's created in the background, and it was a few seconds. Here it is. It's less than 2 seconds for creation. Regarding changes, that's what we're working on actively. How to make it all changes and migrations of databases. Changes schemes on data, goes through versions, systems, Flyway, Ruby on Rails, or Django, or others. How to make it, how to check it on real data, and so the private data is not leaked. And there are many horizons in difficulties, but we want to cover it 100%. And my presentation was about that. Today I wanted to show you live and have slow internet that here we catch dangerous log with configuration every second. We got some logs and wasn't permitted more than 5 minutes deployment. And every second it's all good, and then all of a sudden we had some large log and for branches and was creating best concurrently. So we checked this release without any backload, and we've seen there are dangerous logs will be issued to prod, and we cannot do it. And it's marked as failed, and CD pipelines and issues and pull requests and specifically a link where it's coming from, some commit, some triggered it. Its integration with your CI tool is there so far is basic, and the threshold entering, but it's working with tagging, and you can understand details. You can have a summary and understand what was wrong, and this release automatically be blocked, or it will go through review. And so it's a fresh story, and I think in the next 36 months we're going to make it, regardless where you locate it, which CI tool or where you keep the code, which environment, you'll be able to easily tune this, and regardless of the language or programming and migration system. We want to make it for all. It's very convenient, and we're working on that. If you have any specific requests, and we are at the point where any project which is interesting can get earlier for your tools. It would be interesting to try, and we can improve integration with specific tool, and just need good feedback from you experimenting and use. I repeat that we have open core model. It's open source, it can be used, some do it, large organizations do it, but there is a simplified cloud interface, GUI access control, additionally various tokens. It's all for payment and closed, but you can get a large discount having talked to us and disregard any prices. We'll review prices many times. We just start this story. Of course, we want to make some money. We'll move faster, including development of open source, and resolve these gaps. Like the first gap is not resolved yet, and I have the need of programmers and with knowledge of Postgres, so that to work on Postgres checkup, we don't have enough people. It's obvious, but it's open source if you want to work on open source. So you can come full-time or part-time, but of course you want to make money. There will be a certain price, but we at initial, especially for Russian-speaking audience, I'm ready to give discounts. Like, I hope I said enough. This not to be blamed in advertising. Let's go to questions. I think that's it for slides. So the result, 3 principles. We have these 3 gaps. First principle, you need a simple process, need to be unified tool. If you want to grow your organization, you need to describe the process, methodology of analysis, micro, and how to switch from one to another. That's the first gap. Second gap is each developer should have the opportunity to experiment, make mistakes, only mistakes, and makes it possible to learn one base, one person principle. It's temporary copies, so we can give it, we'll already make it with data lake engine. And third, need 100% changes should be tested and with human review. Many already have it, those who listen, but you need to look with your eyes on the code. Even super experienced engineers and experts miss some problems. You just need to execute and see how. Turned out to be convenient, although we did it for optimization initially, but now for testing changes in CI is also convenient. Now, as a link on a previous presentation, that's about it. Postgres AI, you can enter. So picture from Lisovsky. It's an interactive site. There are some extras. We'll not deal with that. Let's move to Q&A. We've been working for 2 hours. Can start to round up. Okay. Thanks, Alexander, for this link. Now, why lock happens on data fetch? I'll keep it so that you can see the links, my contact details, if you want to get in touch. So the lock happens on data fetch. All locks is there until the data is cleansed. So why it's on data fetch? Well, it depends. Possibly the fetch is running, but before that you locked some points, and then you fetch, and then you wait. You cannot lock new rows and other rows, and you have a deadlock. And deadlock is not pleasant always, but it happens. You need to review work with transactions. Make this situation less curious and lock in the end. I'll take another batch and avoid this issue with locks. What's the name of the person on Citus? Ambrose Freud. Let me check. It's about timing. I'll send the link to the chat. Write your questions, please. Andres. These articles were a month ago in Microsoft blog and Cyphers. It's all bad with my internet. So the internet tells it's time to wrap up. I'll give you the link after we finish the broadcast. So if you have any other questions, please go ahead. While you write your questions, I'll remind you that you can vote for this masterclass. Don't forget to put some stars. There was a question in the beginning. Stanislav Kolesnikov, why select one is so bad? Well, it's not so bad, except the thing that it slightly loads the database. Postgres can sustain a lot of It doesn't work with disks or anything. So no problem with that. But application is slowing down on round trip time. The time is required to get in the database. At the same time, the number of overhead is growing gradually. I mentioned PG Bouncer. It's also a transaction. And we noted when there are many transactions, you have select one, possibly 50% of this select one. So PG Bouncer at a certain point cannot be scaled up in more than one core. It's not paralleled, and you'll have 100%, 15, 20,000 CPS. And could be 50% of select one. So you will need a second PG Bouncer, although you need to remove select one. It could be more complicated select set requires processing, and then you will have more processing for results of select from the side of application. Another question, Maxim. How instantaneous cloning is implemented on the database? Instantaneous. Well, based on copy and write, I don't want to repeat. You can read it on the website in detail. And I just made a presentation where I explained it in detail. So many people heard it. It's copy and write. So we don't copy when we issue a clone. All clones are shared. All blocks of data, same blocks of data, until they are changed. When they are changed, they are different. But in the beginning, we don't change. When we experiment, 1, 2 tables, it's not the whole database. So we just write deltas. It's represented, is supported by 2 ways of LDM, not recommended. The first is more stable, is more rapid, it allows time travel. Well, this was about database level. Lab. By the way, optimization is useful to travel on time. You might want to know about plans for today, yesterday, whether they changed. If it's all set with snapshots, like for each 6 or 12 hours, you can go back to yesterday and see what were explain analyze buffers on yesterday's clone, and to see whether there was degradation. You have an ID and roadmap, regression control to automatically control the group of queries before and after release, especially if there were regressions. And this will be done in lab conditions. We don't want to load production. You can even make it in CI. It's a standard practice of check. Many people automate it in CI. It's not related to development and depends on the CI. Question for production could be any file system. Yeah. So no limitations here. Yeah, it's a good point that we don't require. It's good if you have physical backups. Then we can take data from backups and not production. Well, I found an article and I'll send it to the chat. There's one analyzed interesting problem. They all have PG bouncers, and it's all started with analysis on max connections, and that it's bad to put 3,000, 5,000, some keep 2,000. Why a lot of idle connections is bad? Because overhead for memory is there. Or if you look at the prog and you see how much memory is used by a backend, and turns out they use tens of megabytes, so 1,000 idle connections is bad. And this article, or before that, he studies that memory is not a problem. It's not a problem with memory, but with working with snapshots, and some ideas can be improved in the future. So over there, he studies and understands how much memory was taken by backend. Okay, work with ORM. Interesting question. If it's Rails, and they started using interesting extension, which is called, I'll write it in chat.
On Rails, there's extension marginalia. I don't know whether for other ORMs there should be similar analogs. So this extension adds a comment to each query, which says these pieces of code were involved in this particular query. This cluster, this control. Initially, what they did, they started adding this at the end. And this is a case where it's a whole long story to coordinate this restore. And then time prevents us from increasing this. So the most complicated queries are long and complicated, so the comments would be truncated, would be cut off. So they would start putting comments at the beginning, but then their query would be truncated, would be curtailed. There's a correlation, but the marginal also make this correlation. Does this correlation? So, using this correlation idea, we can also combine these PG stats statements. And marginality tells you this code was generated there. You can also have other tools, Datadog, for instance. I think memory serves its application performance monitoring at APM. There's also New Relic, another tool. It's also expensive, so you should ask for discounts, and it works. So these tools can trace SQL and can tell you, can show you stack trace where this particular SQL comes from. But the timing always switches on the network and the overhead starts working, the application works. It's not a true database timing, but this is okay. It also aggregates parameters, etc. But in these tools you can check. This is another way to do macro analysis. And it is good because it also does micro. I live on the database side, so I find it quite seldom. I see other people use it. I see that this is a good thing. But if you're more a developer, and if you can use these tools, APM or the Datadog, then there'll be some SQL analysis for sure. It will check where the query comes from. So you need to optimize your ORMs in this way. So this optimization is a huge topic in itself, but quite often you want to see where this query comes from. It's a real pain, and this is the way to solve it. Furthermore, there's this n+1 select. High frequency caching. You can do this using microanalysis, right? You do use this backup and you use a build or a cloud on the machine. Yes, that's most definitely the case. It depends on your expectation, how many clones you need to have, how many clones will be under a load, etc. And we deploy our from the backup, from the logical level. Furthermore, disks are rotated now. You can use a battery of disks, and you can restore the new disk based on the schedule. The old one is taken out. This is the database lab engine version 2.2. But basically, at the physical level, it's while ship, it's replication, physical replication. but you want to have zero risks, right? So this is a good case. You draw it from backups, and usually the delay will be just a couple of seconds. Usual replica. Look at the previous report. I laid it forth in every detail. Yes, there's a special slide which shows how it works, what the sequence is, what the opportunities are. Yeah, how to make screenshots, etc. It's all open source. You can have a look at the code. Furthermore, we use this magic: one machine with one disk, or with one array. Say, let's say 1 terabyte, and you can make 20, 30, 40 clones. You can set up how many clones you're going to make. We can work around the clone, tell that this is not important. Shared buffers are small, and it's not taken into account, which was a great relief. Previously, it was a life and death matter, right? Shared buffers are not taken into the planner at all, so it does not take into account the real amount of memory. Work memory is important. And we take everything from production. We show that the data are the same, statistically the same. And the magic is that you have one machine, one disk, but 20 bases, 30 bases. You give them to people as many as they need. As long as the CPU works. But physically, it's one machine, 10 developers, but logically, it's just one base. Like I said in the previous report, Steve Jobs would say one developer should work with one database. If it's one developer, he should have one personal copy of a database to start filling it, to start making errors, to start learning along this way. And Steve Jobs, when he designed this personal computer, well, we want to be the same. We want to make a personal database. We still have to understand what we can do in this respect. It's so cool watching other people do things, when they start experimenting, when they start improving their codes and their knowledge. And the way you develop these changes and optimize. Yes, ZFS shots, and then you use the clones based on the snapshots. You can select the snapshot, and the clone is already read and write. And it all works copy and write. Thank you, Artyom, for the links. Question about the cloud. Can you work locally? Well, you can work from on-prem, you can work locally, and in any cloud provider, the machine is what is important, and the disk. And copy and write. Yes, what are the requirements? Should be a machine with Linux or Ubuntu. Should be the latest version of the core. The version 2.0. And the disk, yes, the data should be an allocated disk, maybe a number of allocated disks. One more thing. We're definitely going to develop integration with clouds. This is what we aim to do. We need to make the threshold lower. But clearly, cloud is still an exotic option for Russia. But you can visit us at the website. You can see our resources. There's an example with Kiwi and with Estek. It's a Korean company, and they have like 50 cases of this kind. And they are not using any cloud. I'm sure about it. Have a look. There are these PDF about the success stories. And we have a chat in Telegram. It will be a chat about Slack engine. It's a Russian language chat. The English language chat is just Slack. The Russian language chat is more active. You can ask your question and we can tell you what to do. So there'll be two gaps that clouds are going to cover. Gap one is about observability and about monitoring and tools. And we hope to improve things. So it looks like we're done with questions. I need to go to the special chat. Okay, I'm leaving for the special chat. We can continue our discussions there. All right. Thank you. Artyom, Nikolai, thank you very much. An excellent masterclass. Thank you very much. Thank you. Thank you. Guys, have a good week and see you there.